back. Welcome back, my dear students. This is Dr. Osama Kashwa, your teacher. And today we will talk about a very important topic in statistics. I hope that everybody it will be easy. I'll try to make it easy as much as I can. To go to this topic right now is that we have to share the screen first. Then, yeah, here is the main source of what we are going to discuss today. We talk about the hypothetical thesis and how to put hypothetical 1 and hypothetical 0 and how to formulate the hypothetics. Today, we will talk about very important topics in the hypothetical tests. We talk about the Z when we use Z tables, when we use the T tables. If the sample is less than 30, then we will use T tables instead of Z. And we talk also about the proportion. And we said in the proportion, all we will do is we will have, like this example, P hat minus P divided by P, Q divided by N. So P hat, P hat, which is the average of the population, minus, like you have here, the average in the sample minus the average of the population divided by the average of the population 1 minus the average of the population again. Okay. Then we will get this, we'll call it t-test, or we will call it p-value, or we'll get from that the test, like with the comparison. Okay. What about the confidence interval? Creating confidence interval. This is very important topic, to create a confidence interval. For the population means when the population standard deviation is known. Okay, if I have the standard deviation of the population is unknown, I don't know it, I will use S instead of sigma. Okay, in this formula, X bar plus or minus 1.96 S divided by the sample of the sample which you had, the sample units, how much the sample units. Okay, if even the sample is over 30, I can use this for the confidence interval. I can use this relationship for the confidence interval. Okay, X bar, this is the sample's mean. So if you give me the sample's mean as example in a number, okay, 50 or 100 or 7.19. So here in this example, a sample D of 30 babies. So N here is 30. N here is 30. Born in 2013, had a mean weight of 7. So the average of the mean weight, the average of the sample is 7.19. So X bar will be 7.19. With a standard deviation, this is also for the sample of 1.4. So the S will be 1.4. Okay. The 95% confidence interval. 95% means I will look for the T in the Z table. I will find the value in 1.96 confidence interval for the population mean of all babies. So if I want the confidence interval for the all babies, this will be the relationship. Let me do it on the board, take the information, then we'll use it on the board. Okay, let us do like this. My own. This is how we will create a confidence interval for a sample of more or less than 30. But the standard deviation of the population is unknown. The standard deviation of the population is unknown. When we go back to the examples and the sets of the examples itself, we'll see the following. That standard deviation, for example, sample D of 30 babies, then N will equals 30. N will equals 30. And let me take out the information which I need to solve this problem. I'll take out from the words. N will equals 30. Okay, because he said here, if you see, for example, D of babies born of 30. 30 means the sample is 30. Had a mean weight of, okay, this is in the sample. This is the sample's weight. So the sample, I will give it this X bar. Sample will be X bar. Sample will be X bar. Will equals how much? 7.19 lbs. 7.19. This is in the sample. Okay. With a standard deviation of, also this is for the sample. So I said, if the sample, if the population standard deviation is known, let me show it to you back, write it back here on this other side so that it will be clear for everyone. I will write it here in this area. What I want to say is, if, okay, I will write it here down in this area, okay? If I have now standard deviation, standard ST DEV, which stands for the standard deviation. If it is known of, I'm talking about the population. If it is known for the population, then I will do it with this simple sigma. If it is unknown, the standard deviation of the population is unknown, then in that case, I will use the sample. I will use the sample one, the sample, instead of using the standard deviation of the population itself. I will use the standard deviation of the sample instead of the standard deviation of the population. In case I don't have the population, the standard deviation of the whole population. Okay. So the standard deviation of the population, if it is known, I will use sigma. It's only difference in the symbols. But if it is unknown, I will use S. S is for the standard deviation of the sample. So this is standard deviation of the sample. This standard deviation of the population. So the sigma is for the population and the S is for the sample. Now I don't have the population here. All I have here is the standard deviation of the sample. I have here, after you saw all this, I have here the standard deviation of the sample. Let me stop sharing the screen and getting back to this example. Again, he's saying in the example, he's saying in his example that, for example, sample of 30 babies. So N will be 30. N will be 30. Of 30 babies born in 2013. You have it here, and born in 2013. So born, okay, this is no problem about the born time. Had a mean weight. The mean here is of the sample. So this will be X bar because mean is the average. This is the average of the sample is 7.19. The average of the sample is 7.19. That's perfect. Okay, so X bar will be 7.7. Okay, and then the same time with a standard deviation of 1.4. So the standard deviation this time, S looks for the standard deviation, but I didn't write it sigma. Why I didn't write it sigma? Because as I told you before, the standard deviation of the population, if it is known, if I know it, if you give it to me, I will give it the sample sigma. This is for the population. But unknown, then I will use S instead of sigma. In the formula, I will use X. Okay, so S here is 1.4. S is 1.4. 0.4. Perfect. S is 1.4. That's very perfect. And in the same time, he said what he wants, the 95% confidence means that alpha is 5%. That means this is 1.4. He's saying is alpha is 5%. And the confidence, that means the confidence is 95%. Then this means that I will look at on the Z table on 1.96 because I know it now. I know that alpha 1 is 5% and or the confidence is 95%, that alpha, that this will be 1.96. Okay, what is the relationship, or what I will do now? What he want confidence interval. Then we'll write down the confidence interval will equal, this is relationship. The relationship is X bar plus or minus X bar plus or minus 1.96, which was the degree of what we need, 1.96, which is the alpha that replace for me this area. Alpha is 5%. Then I will replace it all with 1.96. Okay, times S divided by the sample of N. Then when I substitute in the formula, X bar is 7.19, 7.19 plus or minus 1.96. Now I put it back, 1.96 times ds. The standard deviation of the sample is 1.4 divided by the root square of N. So the confidence interval means between. The word confidence interval means between. This word confidence interval means between. Between what? Between two variables. That's why here we put plus and minus between those two variables. So once it will be plus, we will make it like this: 7.19 plus this amount. Then the second time we'll make it minus this amount. Once it will be plus and once it will be minus. So when it will be plus, it will be with equals. For the plus, it will equal 6.7. Okay, when I do it with minus, then it will be also 7.7. So it will be between 6.7 when it was minus and 7.7 when it is plus. Let me show you how I will calculate this. It's very easy. Let me show it to you how I will calculate it. I will do it here in this area. So 7.19 plus 1.96 times 1.94 divided by the root of 30. Of course, the sample here is 30. So divide by the root of 30. This will equal 7.7. Then back, I will go the same relationship, 7.19 plus 1.96. This time is minus, times the 1.4 divided by the root of 30. And this will give me 6.7. So the confidence interval is the value between both of them. The confidence interval is the value between both of them. Thank you so much for listening to this lecture. Thank you.